Hello, welcome to your fourth video lesson on organic chemistry. Today we're going to be having a look at cracking, what it is, how it happens, what types of exam questions come up and things like that. Okay, so in the spec, this is what AQA expect you to know, remember and apply, or understand and apply. So hydrocarbons can be broken down, which is another word for cracking, to produce smaller, more useful molecules. Cracking, there's a couple of ways you can do it. There's actually more than that's in the spec, but the spec just expects you to know catalytic and steam cracking. You need the general terms and conditions for both of those types of cracking. What cracking produces, so we have an alkane and alkenes. The reason we crack is because there's a high demand for fuels with small molecules, like these in petrol. So the products of the cracking are actually useful, and they're fuels. You should be able to balance symbol equations for examples of cracking given the formulae of the reactants in the product. So they won't expect you to figure out what is produced or isn't produced. They will always give you the products, whether it is a name or a formula. You should be able to give examples for the usefulness of cracking and why we as modern day humans depend on these hydrocarbons. So before we get into cracking, what it is, this type of question comes up quite a lot in exams. It's expecting you to use common sense and what you can pull from graphs. You don't have to know any of the chemistry to be able to answer this 2-mark question, okay? So it's worth 2 marks, so it would be 2 minutes in exam conditions. It's asking how the relative supply and demand for petrol and diesel fractions cause problems for an oil company. So you've got on your graph, you've got the supply and demand being in the dark grey and the supply being in the white colour. And you've got 2 fractions, you've got your diesel and your petrol, okay? So break the question up. It's asking how the supply and demand for petrol and diesel fractions cause problems. So the first one, have a look at how diesel, the supply and demand for diesel, why that might be a problem. And then have a look at how the supply and demand for petrol, how that might be a problem. Okay, pause the video, write your words out, and I'll show you the mark scheme in a minute. Okay, hopefully you can have thought up 2 separate points, one about diesel, one about petrol. So the mark scheme is this. So you're allowed for the first mark, there's a shortage of petrol or the demand for petrol is higher than the supply. And then for the second mark, you're allowed diesel is in excess or the supply of diesel is higher than the demand. Okay. You could have also compared them. It wasn't a compare question, but you could have said petrol had a low supply and diesel had a high supply. And petrol has a high demand and diesel has a low demand. If you didn't specify petrol or diesel in your answer, you can only get the maximum 1 mark, okay? So it's really important you don't use the words it, they, them, things like that in your exam questions, because if the examiner isn't clear on what you are talking about, they can't give you the marks, okay? So why we need cracking. On your screen, you've got a couple of different ways of displaying some numbers. So this top right-hand corner Sankey diagram, almost like, This is from an AQA exam question, so it's a graph they might show you in an exam. So you've got the fuel, the crude oil that you pull out of the ground, 100% of it. The heavy fraction is 50%, and then you've got paraffin, diesel, and light down the bottom. If you looked at the scale, you'd be able to work out that that would be 40. Oh no, if that's 50%, you'd be able to work out these percentages using the graph paper. They might also show you a table like this one on the left, where you can see the percentage found in crude oil down the right hand side. Okay, this is for Gippsland crude oil, which is a place. So it's basically the crude oil they take out of the ground there. You can see here we've got about a third of it being heavy residue and heavy gas oil, a third of it being light naphtha and heavy naphtha. So naphtha is used to make chemicals. Kerosene, light gas, oil again there, and the gases being 2%. So wherever you are in the world, there's slightly different fractions or slightly different percentages of each fraction. So it depends on where you dig the oil up from, depends on how much of each fraction there is in oil. It just depended on the temperature and the pressure at which the crude oil was formed at and for how long. But across the world, there are always too many of the heavy fractions. So this heavy fraction here and this heavy fraction here, okay? We can't fill or fix our roads quick enough for the amount of oil we are pulling out of the ground. So bitumen only has a few select uses. So it's used for tar on roads, and it's used for tar on the top of flat roofs. It's also used as an adhesive in some industrial applications. They used to use it a lot in houses. So I have some floor tiles in my house that were stuck down with bitumen. But we still don't use it all up. There's too much supply for the demand that we have, basically. The lighter fractions, so the gases, the naphtha, the petrol, there's not enough of those, and we use those for fuels a lot. So our demand for those is way more than they can supply by just digging it up out of the ground. So what they can do is a process called cracking, okay? So they will have these really long alkanes that we don't really have much use for, okay? They can be split up into shorter alkanes that we can actually use for fuels because they burn better. And an alkene, that alkene's a byproduct, but that byproduct can be useful as well for making polymers or plastics. Ethene, for an example, is a starting material in a lot of pharmaceutical drugs as well. So they might show you a symbol equation like this one down here. So we've got octane, hexane, ethene. Okay, so we've got a long alkane, ANE. So double it and add 2 for our hydrogens. Hexane, another alkane, double it and add 2, so our hydrogens. And an alkene, just double it. Okay. They might also show you it in pictorial versions. Oops. Can't see that underneath the... There we go. So they might show you it in the displayed formula as well. So it's the same equation as the one above, but I've just put this structural displayed formulas out as well. They could show you any of those. The word equation, the symbol equation, or the structural displayed formula. They could ask you to fill in the blanks blanks. So for example, if they gave you the word equation and they missed out the symbols for ethene, they might ask you to fill in the symbols for ethene as part of a question about cracking. So we know breaking down long chain hydrocarbons into smaller ones is called cracking. Why we need to do it. So there's a little complete the paragraph down there. See if you can do it. See if you can figure out and display your understanding of the knowledge you've just learned. Okay. If you want to pause the video and copy and complete it in your book, that would be great for some revision notes as well. So I'll go through the answers. So we've got the graph showing us there's a very something demand for long chain hydrocarbons. So if you go to the longer chain, okay, and it's asking us about demand, so we need to use the key and look for the dark purple. So we have quite a low demand for these long chain hydrocarbons compared to the other ones. So I would say low for this one. Whereas the short chain hydrocarbons are much more useful and have a higher demand. By cracking the long chain hydrocarbons, that's the word that would be missing there, we can meet the demand for the short chain hydrocarbons. So remember, supply is what we can dig out the ground and demand is what we need or want. So they might show you an exam question like this one. So octane, one you're not expected to be able to name. So it's giving you the formula there, is a hydrocarbon in petrol. Cracking breaks down into smaller molecules. Which molecule can be cracked to produce octane? So octane needs to be on the right-hand side of our equation. Hopefully you've had a chance to have a look at those, okay? Remember we have a large hydrocarbon broken down into a smaller one, and this is going to be our smaller one. So we need something bigger than C8H18. Well, C4H8, that's not bigger at all, that's smaller. C4H10, again, too small. C8H16, nope. C12H26. It's our only possibility, okay? So the answer to question A is C12H26, okay? So you're expected to be able to complete symbol equations based on balancing, okay? So normally with symbol equations, whatever is on the left-hand side must equal the right-hand side. Okay, so it's a little bit of subtraction here. So if we start over here with C30, here we have C10, and we need the total of these two to add up to 30. So you can fill in the blank there, that would be C20. Your H's have got to add up to 62. We've got 22 here, so we need to add on another 40. So it would be C20H40. Okay, pause the video, have a go at the rest of these questions. Remember the total amount of carbons on the left-hand side has got to equal the total amount of carbons on the right-hand side, and the same with the hydrogens. Okay, so let's go through some answers. So the top one we said would be C20H40. The second example, we have C22H42. The third one, we'd have C10, and then we'd have H22. Doing a little bit of mental maths there. Now the fourth question is a little bit harder because we've got 3 products. We've got this product, we've got the missing product that we've got to work out, and we've got this product as well. Okay, so the best thing to do would be to add the carbon numbers on this side. So that's 26, and then work out how many you need to get to 35. So that's 9. So it would be C9 that's missing here. And then do your hydrogens. So you've got 54 on the right hand side, and you've got 72 on the left hand side. So you've just got to do 72 take away 54. So it would be 18 H's, so it would be H18. The final one would be C27H56. Okay, remember in the exam you do get a calculator. You can type that out on your calculator, press all them buttons, rather than relying on your mental maths. Okay, so they might show you something like this in an exam question. So write the correct formula for the third product. So we've got an alkene here, an alkane there, and we just need to work out what we produce here. So we know our total C's are 10, our total H's are 22. Figure out what's missing on this right hand side. It's worth 1 mark, so it would be 1 minute in an exam. So the first step would be to add up what is already on the right hand side. Okay, start with our carbons. So we've got C5 and C3, so we add those together, we get C8. Okay, on the left hand side we have C10, so we need to figure out what's missing. So we do 10 take away 8, so over here we would start with C2. Then we'd look at our hydrogens. We have 10 here and 8 here, which means we've got 18, and we need 22, so we'd have H4. So C2H4. Little bonus question, can you remember what C2H4 is called? Well, we know because the H number is double that of the carbon number. It's an alkene. And we know it's got 2 carbons. So you can work down the prefix names. So we've got meth for 1, eth for 2. So it would be ethene. Okay. So we've got our formula there. Another example, decane can be cracked to produce ethene and one other product. See if you can work out what's missing. Okay, the mark scheme says the answer is C8H18. Okay, now something that comes up every single year, and it has come up in both the trilogy and the triple foundation and higher papers. So it has come up in 4 exams for the past 4 years. We don't have access to this year's papers yet. I don't know if they'll release them or use them for resits. But for the past 4 years, they've questioned the conditions for cracking in every single tier and type of exam. So it's really important that it's something that you commit to memory, okay? So in your spec, it expects you to know the conditions for catalytic cracking and steam cracking, okay? So we'll go over those. There are 2 different ways to crack long alkanes into shorter, useful alkanes and an alkene. There are other ways of doing it, but these are the only ones that they have to remember for the specification, okay? So we have catalytic cracking on the left-hand side here. So that is using a catalyst. Remember, a catalyst speeds up the rate of reaction without being used up. So for catalytic cracking, you need a really high temperature of 550 degrees C or higher. And you need a catalyst, okay? So you need a very hot catalyst. The catalyst that's used is called zeolite, which is a mixture of aluminium oxide and silicon oxide, okay? Now you're not expected to remember this catalyst or the types of compounds that are in the catalyst, but it is allowed people in the past to get marks on exams, and I'll show you that in a second when we have a look at some exam questions, okay? On the right hand side we have the other type of cracking, which is steam cracking. So we have a very high temperature of 800 degrees or over, and you have water there. Now obviously at 800 degrees water is going to turn into steam, which is why it's called steam cracking, okay? Now we don't want oxygen present in either of those 2 methods. Reason being is really high temperatures and hydrocarbons, which are very flammable, and oxygen, if you put them 2 together at a very high temperature, they're going to set on fire. So we don't want oxygen in either of those conditions, which means you may have to take that oxygen out of your reaction vessel, okay? So you get, sometimes they give exam questions where they show a image and they expect you to pick out what the catalyst is or what the reactants are or where the products are and things like that. Sometimes they're multiple choice questions, sometimes they're fill in the blank questions, sometimes they are just write your own sentence questions, okay? So this little worksheet helps you figure out if you've got some of the learning about cracking, conditions, etc. So pause the video, write out the paragraph in your work, try and fill in the blanks, and we'll go through the blanks in a moment. Okay, so hopefully you've had a go at this. So it says paraffin was the something something we needed to something. So you find paraffin in your diagram, and your paraffin's on the left hand side over here, okay? That means this is going to be your reactant. So we know paraffin is going to be cracked to produce shorter alkanes. So we know it is a long hydrocarbon we needed to crack. The porcelain chips were used as so your porcelain chips are here, and they're your catalyst, okay? This allows there to be a surface for cracking to happen, or you could say reactions to happen, but cracking is the better option. The paraffin split up into shorter chain hydrocarbons. Some of the gases released were alkanes, while some were alkenes. Make sure your spelling is correct on that one. We know this because we tested them with something water. You've got some symbols there, Br. If you're not sure, look on the periodic table. Br stands for bromine. So bromine water, we know that's a test for alkenes. It went from orange to, remember a previous lesson, colourless. When we break something down using heat, we call it, now you might not know this, but if we look at what heat is, we call that thermal. And if we break something down, decomposition. So you should have come across thermal decomposition before, but we're breaking something down using heat. Okay? So you might get an exam question like this. Most ethene is produced by the process of cracking. Complete the sentence. Cracking is a type of thermal decomposition. Nice, easy 1 mark. Okay. You might get a question like this, where it says, give the 2 conditions used to crack large alkane molecules. Okay. So we need 2 different conditions here. You can pick catalytic cracking or steam cracking. Doesn't matter which. Okay. I'll show you the mark scheme and what's allowed. So you're allowed to say high temperature. Okay. Try not to say hot or heat or high heat. I know in this mark scheme it's allowed, but in a lot of other mark schemes it's not allowed. You're allowed to state a temperature. Okay, so remember those temperatures we had, 550 degrees or 800 degrees. And then for your second mark, either catalytic cracking or steam cracking. So you either need a catalyst or steam. Okay. Now again for this mark, it's allowed you to state a named catalyst. So zeolite, aluminium oxide, silica, which is silicon oxide, or ceramic, which we saw in the previous question. You're also allowed without the presence of oxygen or air. It does say ignore any references to pressure, which is why I've not told you the pressure. Normally they use a high pressure for catalytic cracking, but they don't for steam cracking. Now this question comes up a lot. Always worth 2 marks. Always need high temperature and then either cracking, catalytic cracking, so a catalyst, or steam or water for steam cracking. Okay, it comes up every single year. Okay, so hopefully you've understood the lesson. You can answer these questions. If not, now's the time to find maybe some flashcards, make some flashcards about the conditions for cracking, what cracking is. Maybe have a look at some more worksheets on cracking. Okay, bye.